Hi and welcome. Let's talk about laws of exponents. First, we have product law. Add exponents of the variables that are the same. Now we have an example, x to the power of 5 times x to the power of 6. So as you can see, they have the same variable. So all we need to do is to copy the variable, and then we copy the exponent, which is 5, and we will add it with the other exponent, which is 6. Alright, now copy again the variable x, and then we add 5 plus 6, that is 11, and the answer is x to the power of 11. That's how we do the product law. Next, we have another example, a squared b cubed times a b to the power of 4. As you can see, we've got two variables on each terms. So we're gonna focus first with the variable a. But as you can see in the second term, the a doesn't have an exponent there, but there is an invisible one. Alright, so we should remember that one. Okay, so we're gonna put a here, then copy the exponent 2, added with the exponent 1. And then we're gonna proceed with the variable letter b. Okay, so we're gonna write b, and then the exponent 3 to be added with 4. Alright, so that's how we do the product law. Next, we're gonna add the exponents together. 2 plus 1 equals 3 for variable a, and for variable b, we've got 3 plus 4, which is 7. So the final answer is a cubed b to the power of 7. The next law of exponent is power law. The internal exponent is multiplied to the external exponent. Let's have some examples. We have here the quantity of x to the power of 5 all raised to cube. Now, 5 is the internal exponent and 3 is the external exponent. So we need to multiply these exponents. So first is we copy the variable, which is x, then write 5 multiplied by the external exponent, which is 3. Alright? Next is we are going to write the variable again, which is x, and 5 times 3, that will give us 15. So the final answer is x raised to the power of 15. That's how we do power law. Another example that we have here is this, the quantity of m squared all raised to the power of 10. So first we copy m, then copy the exponent 2 times the external exponent, which is 10. Now, again, copy the variable and then multiply 2 times 10, which will give us 20. That's how we get the answer m raised to the power of 20. Next one is product of power law. The external exponent is multiplied to each of the internal exponents. This is quite similar with power law. Example number 1, we have the quantity of a squared b cubed all raised to the power of 4. So as you could see, inside of the parentheses there are two variables already and two exponents or internal exponents. So the 4 is needed to be distributed to the internal exponents, and we're gonna use multiplication for this. So we're gonna have the a first, and then copy the exponent 2 multiplied by the external exponent, which is 4. Next, let's have the variable b, and then the internal exponent, which is 3 multiplied by the external exponent 4. Alright, that's how we do the distributive one. And then let's copy a again, and 2 times 4, that's 8, and variable b, then exponent 3 times 4, that will give us 12. So the answer is a raised to the power of 8, b raised to the power of 12. Another example is the quantity of x, y squared, z to the power of 5, all raised to cube. Alright, as you can see, we've got 3 variables here, And mind, the variable x doesn't have an exponent there. However, there is an invisible one. Again, always remember that there is an invisible exponent 1 if you don't see any exponents at all. Alright? Now, we need to distribute the exponent 3 to the internal exponents. Alright? That's how we do the distributive. So let's begin with the variable x and then copy its exponent, which is 1, multiplied by the external exponent 3. Next, let's have the variable y. And then we write the exponent 2 multiplied with the external exponent 3. Alright? And then we've got variable z, and we also write the exponent 5 multiplied with the external exponent 3. Now let's get the final answer. So we'll have first the variable x. So we're gonna write x here, and then multiply 1 times 3, that will give us 3. Next we have the variable y, and then multiply 2 times 3, we've got 6. And for variable z, we're gonna multiply 5 times 3, and that is 15. So the final answer is x cubed y to the power of 6 z to the power of 15. Another one is the quotient law. Apply subtraction or minus to the exponents that have the same variables. Let's have some example. We've got here x to the power of 6 over x squared. So if you see a formation like this, all we need to do is to subtract the exponents. So first is to copy the variable that are the same, which is x. And then we write first the 6 and then subtracted by 2. Alright? Then we'll copy again the variable and then do the operation 6 minus 2, and that will give us 4. So the final answer is x raised to the power of 4. That's how we do quotient law. Another example we have is a raised to the power of 5, b squared, c raised to the power of 4 all over ab. Alright, now as you can see at the lower part, a and b doesn't have any exponents. However, there is an invisible one on each of these variables. So we should be very careful with that. Alright, now let's start doing the solution. So we're gonna have first the a, and then write the exponent of a, which is 5, and at the lower part we're gonna check the exponent of a, which is 1. So we're gonna copy 1 over here. Next, let's have the variable b, and then copy its exponent, which is 2. Then we're gonna check at the lower part if there's an exponent at b, and there is, which is 1. So we're gonna copy that. And then let's proceed with c, and we're gonna copy c raised to the power of 4. However, at the lower part, since there is no variable c, we're gonna have just c to the power of 4 at is. Now we're gonna do the operation. So let's have first the variable a, and then 5 minus 1, that will give us 4. And then let's have variable b, then we're gonna have 2 minus 1, that will give us 1. So we're gonna write 1 here. However, the rule is 1 should be an invisible, so we should not put 1 at the final answer. Please remember that. And for the c to the power of 4, since it is at a, so we'll just need to copy that one. Okay, final answer is a raised to the power of 4, b, c raised to the power of 4. Next we have is the negative exponent law. This law is connected to quotient law. When the quotient has the negative exponent, the negative must be eliminated since negative exponents are not allowed in polynomials. Thus, the term that has negative exponent must be written in fraction form, particularly placed on the denominator part and let 1 as its numerator. So let's have some examples. Now we have here x cubed over x raised to the power of 8. So we're just going to have the same process with quotient law. So we're gonna copy first the common variable, which is x, and then copy first 3 minus the exponent 8. Alright? Now, as you can see, we have here 3 minus 8. The minuend is less than the subtrahend. If the situation is like this, automatically the answer is negative. Alright? And then we're gonna do the other way around, 8 minus 3, that will give us 5. So we have here the answer, x raised to the power of negative 5. However, negative is not allowed in polynomials. So we need to rewrite this one into fraction form. So we're gonna have 1 as the numerator over, and we're gonna copy x raised to 5. Negative, or the sign which is negative, is eliminated already since we transfer it into fraction form. So the final answer is 1 over x to the power of 5. How did we get the final answer? So all we need to do is to copy the term that has a negative exponent, which is x raised to the power of negative 5. And then we are going to divide it by its positive and negative form. So we have here at the lower part, quantity of x, negative 5, multiplied by x raised to the power of 5. And then we're going to cancel out the x raised to the power of negative 5 since they are just the same. And the remaining one at the top is 1. So all we need to write is 1 as numerator. Then at the lower part, the remaining one is x to the power of 5, which is the final answer that we have here. But to have the easier way, you don't need to compute the one that you see on the right side, okay? All you need to do is just to follow this one. If you see any negative exponent, just place it at the denominator part. That will be easier. Let's have another example. We have b squared c to the power of 10 all over b raised to the power of 5 c squared. So we're gonna do the quotient law. We're gonna subtract the exponents that have the same variable. So let's gonna have the variable b, and we're gonna copy first the exponent 2 minus the exponent 5 since they have the same variables. Next, we're gonna have the variable c, and then we're gonna copy first the exponent 10 subtracted with 2. Alright, now let's do the operation. Let's have first the variable b. So it's 2 minus 5. The minuend is less than the subtrahend, so automatic the answer will be a negative. And let's do the other way around. 5 minus 2 is equals to 3. Okay, and let's have variable c. Then we have 10 minus 2, that will give us 8. Alright, as you could see, the variable b has a negative exponent and c has a positive exponent. So if we have a situation like this, all we need to do is to write the term that has a positive exponent at the numerator part. So c raised to the power of 8 will be written at the top, since it is a term that has a positive exponent, and b raised to the power of -3 will be placed at the lower part so that we can eliminate the negative. Okay, so the final answer that we have here is c raised to the power of 8 over b cubed. That's how we do negative exponent law. Last, we have the zero exponent law. If the variable has 0 as an exponent, then it is equivalent to 1. Let's have some example. We're gonna have still an example like quotient law, since zero exponent law is just related with quotient law. So we're gonna have x, since x is the common variable. So we're gonna have 3 and then minus 3. Alright, so we're gonna copy again the variable x, and 3 minus 3, we're gonna have 0. So the answer that we have here is x raised to the power of 0. However, if this is the case, then this term is equivalent to 1. Alright, so that's how we do the zero exponent law. One more example, we have x squared y cubed z squared all over x squared y cubed. So we're gonna apply the quotient law since we're having division here. So let's have the variable x first, then copy 2, and then subtracted with another 2. Next variable is y, and then we are going to copy 3. Then subtracted with another 3. Next, we're gonna have the variable z, and since at the lower part there is no variable z, so we're just gonna copy z squared as it is. Okay, now let's do the operation. So we're gonna have x first, and then 2 minus 2, that will give us 0. Then y, 3 minus 3, that will also give us a 0, and z squared, we're just going to copy that one. Alright, now since we have here x to the power of 0 and y to the power of 0, that will give us an equivalent of 1 to each of these variables, since they have exponent 0, and we put them inside the parentheses, since the operation between each of these variables is multiplication. Now, all we need to do is to multiply the 1 times 1, which will give us 1, and we will just copy z as it is. So the final answer that we have here is 1z squared. However, as what the rule says, if there's a 1, it should be written in indivisible way. So our final answer is z squared. That's how we do zero exponent law. I hope you learned from this video. See you next time.